Gzz, Jedi Zonker here, ready to kick off training session number 2.
Hey, Mr. Z, why are you so extra? Extra? Do you want to save the galaxy? I think you do. Do you want to get your arm sliced off with the lightsaber? I don't think so. Extra asking me. Come on.
Okay, Jedi Zonker here, ready to start training session number 2. One-step equations. In order to solve one-step equation, you must be able to sense things using your intuition. You can feel using the force what is right and what just doesn't work at all. The first important word we must know is equation. This is two math expressions that are equal. The big giveaway for an equation is if it has an equal sign, like these equations below. 2 plus 2 equals 4. X divided by 5 equals 10. 3 times parentheses x minus 1 equals 14. All equations all have an equal sign. Next, let's look at this word substitute, which for now we can think of as plugging in a number for a variable. Kind of like that time I had to substitute for Qui-Gon Jinn in the Battle of Tatooine. I cracked myself up. You might think of substitution like in a sports game. For example, if you switch out from the bench to the field for another player. In this expression down here, x minus 2, if x equals 10, we can take this value, x equals 10, and substitute it in for the x in our expression. That's going to give us 10 minus 2. Again, substituting in that 10 for the x. Now that we have 10 minus 2, we can do 10 minus 2 equals 8, which in this case would be our answer. Here we want to substitute to see if the solution is correct. First we have x plus 1 equals 14. The solution is x equals 13. So first let's take that 13 and substitute it in for our x. That's going to give us 13 plus 1 equals 14. You can see instead of the x, we have put in 13. Now, is 13 plus 1 equal to 14? Well, 13 plus 1 is 14. So we get 14 equals 14. This is a true statement. I'm going to put a check mark. True. Right over here, we have y divided by 2 equals negative 5 with a solution of y equals 10. All right, let's take that y equals 10, plug it in for this y up here. That's going to give us 10 divided by 2 equals negative 5. All right, now what is 10 divided by 2? Well, 10 divided by 2 is 5. Is 5 equal to negative 5? No, that is false. So I'm going to put an X for false. So we can claim that this solution, x equals 13, is correct, and this solution, y equals 10, is not correct. It's false. We can think of this word inverse as opposite. Now here I'm going to ask you to sense using the force. Feel it. We have some inverse operations down here. Now what is the inverse of addition? What is the opposite of addition? Use the force. Feel it, sense it. You said subtraction, didn't you? Excellent, excellent. Subtraction and addition are inverse operations because they are opposite. All right, what about this one? Multiplication. Can you sense, can you feel what is the inverse operation, the opposite of multiplication? Did you say division? I bet you did. I could sense that you did. And you are correct. These opposite inverse operations are very important for us to know. Addition and subtraction are inverses. Multiplication and division are inverses as well. It is finally time to reveal the key to maintaining balance in the force. And that key is right before you. This equal sign. You must always, always remember that this equal sign is sacred above all else. Let's take a look at this example here. If we had 5 equals 5, this is a true equation. The force has balanced. However, if I added a 2 to this side of the equation, you can easily see that we have 5 equals 5 plus 2, which is not true, and balance is lost. But what if I added a 2 to this side of the equation as well? We now have 5 plus 2 equals 5 plus 2, or 7 equals 7, which is true, and balance is maintained. And that is the key to balance. Always, always think both sides of the equal sign. Such is the method that we use to maintain balance in math and maintain balance in the force. And now, my Padawan learners, you have the chance to use your skills of the force to solve one-step equations using inverse operations to solve for these equations below. Let's start right over here at x plus 2 equals 7. First off, what is happening to our variable? Right now, we have plus 2. What is the inverse operation? What is the opposite of that plus 2? Well, it's minus 2. Now we need to apply that to both sides of the equal sign to maintain balance. Minus 2 over here. That's going to be this 2 minus 2. That's 0. Those cancel out. Over here on the right, we have 7 minus 2, which is 5, giving us a final solution of x equals 5. We can check this by plugging it right back in. If I plug 5 in for x to get 5 plus 2, does that equal 7? Yes, indeed it does. And that is our answer. Let's move on over to our second equation. Y minus 3 equals negative 5. First off, what's happening to the variable? It's minus 3. What's the opposite of that? Plus 3. That's our inverse. Let's do that to both sides of the equation. Over here as well, plus 3. On the left, minus 3 and plus 3, those cancel out. On the right, we have negative 5 plus 3, leaving negative 2, and an answer, a solution, of y equals negative 2. Let's check that out. If I plugged in y equals negative 2, I'd get negative 2 minus 3, which is negative 5. That checks out. Moving forward, we've got negative 4 times m equals negative 20. First off, what's happening to the variable? It's being multiplied by negative 4. What's the opposite of multiplication, the inverse? Divide by negative 4. 4 divided by negative 4 is 1. Those cancel each other out, leaving us with 1m, or just m. Now we also need to do both sides of the equation. So if I divide negative 4 over here as well, I have 20 divided by negative 4, which is negative 5. And a solution of m equals negative 5. If I check that out with our original, negative 4 times m, negative 4 times negative 5, does indeed equal 20. Last example here, z divided by 3 equals 3. What's happening to the variable? Well, it's being divided by 3. What's the opposite of that? Times 3. I'm going to put the times 3 right over here on the left. Let's do that to both sides of the equal sign. Times 3 over here. Now 3 divided by 3, or divided by 3 times 3, those are opposites. That's going to leave us with 1z, or just z. On the right side, we have 3 times 3, which equals 9, and a solution of z equals 9. If we wanted to test this back in the original, we get 9 for z. 9 divided by 3 does equal 3, and we have balance. I can see the forces growing stronger in you. I leave you with these words of wisdom. Steps to solve. Ask yourself, what is happening to the variable? Second, ask yourself, what is the inverse? What is the opposite of that? And lastly, our key to maintaining balance. Always apply to both sides of the equal sign. I'll see you at our next training session.